So Bohr's model of an atom, Rutherford's model of an atom, Thomas model of an atom.
J.J. Thomson model of atom. So this J.J. Thomson model of atom and the Rutherford model of atom get failure. Why? Because it is the failure is called as the limitations. So the question will be, what are the limitations of J.J. Thomson's and what are the limitations of Rutherford atom like this? So why these two models get failure? Why?
So it does not show the stability of an atom.
Because in the case of J.J. Thomson atom, he told that all the electrons are negative charge particles are embedded in the positive charge particles. So example you can take as a watermelon. This he said that the seeds are electrons and that rectal parts are the plus parts are as protons. But latest innovations cleared that electrons are revolving around the nucleus. So his idea is wrong. So yeah, it is the limitation of the J.J. Thomson's. Then Rutherford's atom model was also failure. Why? Why? Why ma? Rutherford's atom model was also get failure. Why? Because why? Because what he told that while the electrons are revolving around the nucleus, but while electrons are revolving around the nucleus, the electrons revolving around the nucleus will lose their energy and they will fall into the nucleus. If the electrons fall into the nucleus, what will happen? There will be no stability of the electrons will be cancelled, so the atoms will not exist. So his model also failure. And latterly, the atom model was given by Bohr's. So his Bohr's atom model have some ideas from both the J.J. Thomson and Rutherford, and clearly he gave some identities and gave some laws. According to him, the same, the atoms are revolving around the nucleus. The nucleus is made up of two types of subatomic particles, protons and the neutrons. Already we know that subatomic particles are electrons, neutrons, and protons. Protons and neutrons exist in the nucleus. They will be in the nucleus. The electrons are revolving around the nucleus. So he gave a formula. What formula? Using the formula, we can find that how many electrons can fill an orbit. So the formula is 2n squared. Yes, the formula is
2n squared.
Yes, very good, very good. 2n squared. Using that formula, we can find how many electrons can exist in the orbits. Totally, we know that 4 orbits in the around the nucleus. There are some discrete orbits revolving around the nucleus. That is K shell, L shell, M shell, N shell. Or first orbit, second orbit, third orbit, and fourth orbit like this. So first orbit consists of 2 electrons based on the formula 2n squared. Second orbit 8 electrons, third 18, and fourth 32 electrons will be there in the circle. But outermost electrons can have 8 electrons to complete their octet. Similarly, he also confirmed that while the electrons are revolving around the nucleus, that is in the discrete orbits, they will not lose their energy. They will not lose their energy. They are revolving around in discrete orbits correctly without any distractions. They are distractions. They are revolving around the nucleus. So this is the structure of an atom. This is the structure of an atom. And what are these? We want to summarize the following. So what is summarize following? What I said is summarization. First of all, you want to know about the Bose atom. You want to explain the Bose atom model, and you want to summarize means how these electrons are going to fill using the what formula. So that question also will be there. So you must write as points. Write as points. Okay. Next, coming to the symbols. Coming to the symbols of elements. Just wait. You know what are the symbols of element? You know. You want to calculate the molecular mass and molar mass also. You know that using that formulas here to write this. Okay. So how will you find the number of moles? in an atom. And how to find the number of molecules in atom, like this, you are having these formulas also. Okay. Wait. So you see the mole concept, we are doing this. So see this formula as example. Calculate the number of moles for the following question. Following 52 gram of helium. 52 gram of helium is there. So you want to find the number of moles from the given mass. So here, see here, number of moles is equal to n. So given mass is equal to small m atom. So molar mass is equal to taken as the capital M. So given number of particles, we don't know n is n. And Avogadro number is n naught is equal to, you know the value of the Avogadro number, 6.023 into 10 to the power 23 molecules. So atomic mass of helium is equal to 4 unit. Molar mass of helium is also 4 grams. So number of moles is equal to given mass by molar mass. Given mass by molar mass. So what is given mass there? Given mass is 52 grams. You have 52 grams of helium. Okay. So given mass is equal to 52 and molar mass is equal to 4. Molar means it is an atomic mass of an helium. So we get 13. So number of moles will be 13 moles. Then who is that? Who is that? Please meet yourself. So 1 mole is equal, you can calculate a number also. This is formula, 1 mole is equal to 6.022 in 10 to the power 23 by number of moles is equal to given number of particles by Avogadro number. So n is equal to n by n naught. So given number of particles is 12.044 into 10 to the power 23 divided by 6.222 into 10 to the power 23 is equal to 2 numbers will be here. Number of moles is equal to. So like this, we can calculate the number of moles using this number of particles and the given mass and molar mass using two different types of formulas. We can calculate the molar masses and molar and moles. Okay. So you must also know about this. So here see, calculate the mass of the following 0.5 moles of N2 gas. Calculate, we want to go to calculate the mass. Okay. So your mole is given, you calculate the mass. So mass is equal to molar mass in number of moles. Remember that formula. Mass is equal to molar mass into number of moles. So m is equal to m into n is equal to 28 into 0.514 grams. This is the mass. Then next for 0.5 mole of nitrogen atoms. Okay. So m is molar mass into number of moles. Molar mass is equal to 14. 14 into 0.5, we get 7 grams. And then also for nitrogen atom 3 point. Okay, given number of particles is equal to n. It is another type. The mass is given here. Particles are given. So using the formula, you can use that given number of particles by Avogadro number. So I get 1 by 2. You get 1 by 2. Okay. So after using the formula, m is equal to m into n is equal to 14. You get the answer. 14 into 7 grams, you'll be getting the answers. Okay. So using the like this, using the formula, so you want to find this moles. Yeah. Calculate the number of particles in each of the following. Using this one, I will say one example alone. 46 grams of sodium atoms. From this, we want to calculate the number of particles there. Okay. See here, what is given there? 46 grams means the number of atoms is given mass by molar mass into Avogadro number. So given mass is equal to 46, and molar mass is equal to 23, and Avogadro number is given is equal to 6.022 into the 10 to the 23. So n is equal to 12.044 into 23. Okay. Okay. So like this, we have to calculate this. So using this, while using the problems, you must cancel it. 46 by 23 இருக்குன்னா அதை cancel பண்ணி 1 by 2 நீ காட்டணுங்க. Ready? I give only 2 marks. 5 marks problems I will 2 marks கொடுப்பேன். Solve பண்ணிருக்கு நாங்க solve பண்ணி காட்டணும். 23 and 46 solve பண்ணி you must do it. So solving is very important. நீ அப்படியே பார்த்து எழுதினா I won't give the marks. You must cancel it because numbers are change ஆயிருக்குங்க. Cancel பண்ணி எனக்கு காட்டணும். ஓகேவா? One or two problems will be coming there. ஓகேவா? புரியுதா? Understand of you?
Yes, sir.
Okay. Coming to the coming to the structure of atoms, we can have that. So diagram is very important. Goldstein experiment is also very important. You can see is the Goldstein experiment. Name the scientists what they found. Okay, these are very important questions. Who discovered neutron? Chadwick discovered neutrons. So this diagram, you must want to that wherever diagram is necessary, you must draw the diagrams in science. Okay. See, this question is very important. How the electrons are distributed in the different orbits? The distribution of electrons in the different orbits of atom was suggested by Bose and Berry. The following rules are followed by writing the number of electrons in different energy levels of cells. The maximum number of electrons present in a shell is given by the formula 2n squared, where n is the orbit number of energy levels, index 1 to 3, and the maximum number of electrons in different cells are as follows. Question first orbit, how many electrons will be there? Using this formula 2 into 1 squared, like this, you have to write. Second orbit, third orbit, and fourth orbit. The maximum of electrons that can be accommodated in the outermost orbit is 8. Orbit is 8. Harish Raj, please meet yourself. Yeah. The maximum number of electrons that can be accommodated in the outermost orbit is 8. Electrons are not accommodated in a given shell unless the inner cells are filled. That is, the cells are filled in a stepwise manner. Yeah. So these are the important questions. Next, you are coming to the gravitations. What will be the gravitation chapters? What are the important laws of gravitation you want to see there? What is define gravitation law? What is gravitation law? What is gravitation of define of gravitation? Or state law of gravitation? What is that law? Okay, say the law. So every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the centers of the two objects. This is the law, universal law of gravitation. Why it is importance? Why it is importance? That are all very, very important questions there. Okay. So what is the universal law of gravitation? Every object in the universe attracts every other objects. Okay. The force it is perpendicular to the it is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force along them and centers of the two objects. So define you can see the Newton's first on the force of law of motion law, Newton's first law, second law, and third law, and their examples. Very important. Okay, all the examples questions you have to read there. Okay. So any mainly read in chemistry from the 2, 3, 4 chapters, very important chapters. Yeah. So read it very carefully, very well. Okay. So in physics also, force and laws of motion, gravitation, work and energy are very important. Read all the definitions. Define joules, define 1 volt. Like that will be questions will be there. Small questions will be there. 1 more questions will be there. Read that also. Okay. Okay, ma.